Hey there, so in this lesson I'm going to go over the solution to the problem that I left you with in the previous assignment, and then later on we'll do some more strings. So let's take a look at this. Hover your mouse over the method name again and let's review the instructions. It says that given a string of odd length, return the middle three characters from the string so that the string monitor yields NIT, which is the middle three characters. If the string length is less than 3, then return the string as is. So in the case that we pass a bunny to this method, we get a UNN. In the case of Peter, we get ETE. And for Jamaica, we get the middle three, MAI. All right, so let's solve this together. I've sort of left a stubbed out version here, and all this is doing is taking the parameter that's passed in here and assigning that to a local variable that is of type string. I called it result, and then we just return the result. So we're basically passing in whatever is passed into this method, we're returning that. So if I run this, it's going to run all of the tests that are in this ignore package. So let's hit the play button here and notice that we have some failures. So in the case that we pass a 1, 2, 3, 4, 5 string to this method, it's going to return the string itself, right, with no modifications. The expected is 2, 3, 4, the middle three characters. Same thing with apple, tiger, candy. And the ones that do pass, right, these are either equal to the length of 3 or they're less than length 3, right? And in the case where there's an empty string, it basically returns an empty string in the result as well. All right, so these are passing because they really don't do anything. But for the cases where we actually have to extract the string out from the middle, it's failing. So let's solve this together. And I'm going to first take care of the part where the length of the string is greater than or equal to 3. So for that, we need an if statement, and we're going to do we're going to call the length method on the parameter that's passed in called str, and if that length is greater than or equal to 3, then we want to get the middle three characters, right? Get the middle 3 characters. Okay, I'm just going to take that up here just for documentation purposes, so when you're reviewing this, it's easier for you to remember. So what I'm going to do first is figure out the index position for the middle character. And the way I'm going to do this is I'm going to define a variable called MID IDX, and it's going to be of type integer. And I'm going to assign it the value of the string parameter dot length divided by 2. Okay, and for those of you that don't know how integer division works in Java, and it's actually the same in most languages, is when you divide 4 by 2, for example, they're both integers. If you divide 4 by 2, you get a 2. If you divide 6 by 3, you get the expected result 2. But for example, if you divide 5 by 2, the actual result is actually a 2.5, right? 2.5 plus 2.5 is equal to 5. But in integer division, the remainder is dropped. So 5 divided by 2 is just going to give a 2. If we divide, for example, 9 divided by 2, that's going to be, instead of 4.5, in the case of integer division, we'll just get a 4, right? The 0.5 is going to be dropped off. Okay, so that's how integer division works. So in the case of candy, if we were to pass the string candy, if you call dot length on it, it returns a 5. So when we do this, when we do string dot length divided by 2, it's going to really throw us right in the dead center of that string, and it's going to give us that mid index, right? In the case that of course this is an odd length string, right? So when we do this division, we get the middle index, and then once we have that, then we can call our substring method. So for that, what I'm going to do is result is going to be assigned the str.substring. The beginning index is going to be MID IDX, right, the middle index, minus 1. Okay, that's going to be the starting position, and the ending position is going to be mid idx plus 2. Okay. All right, so in the case where the length is greater than or equal to 3, we assign the result the extracted 3 middle characters. If it's not, then it just basically returns whatever was passed in. Okay, so just a single if statement in here, and let's run this. And notice that all of the tests pass. All right, so for the remainder of this lesson, I want to go over some more concepts that you can add to your arsenal, and that'll help you solve different types of problems. So we created a project earlier called Prereq Practice. So just open that up again and go to Source, and you'll see that there's a package called Practice Strings. So we're still sort of on the strings topic. So open this file up here, and let's get rid of everything in here, make some room for some new concepts. And let's say we have 2 variables. I'm going to define them. We'll say Mike's age. It's of type int, and we're going to say his age is 10. And we'll say Bob's age is 12. All right. Now, if we want to compare both of these variables, we use the if statement, and that goes like this. We say if Mike's age is equal to Bob's age, then do whatever is going to be in here. Do this. Okay. And if they're not, else do this. Okay. So of course, Mike's age is not the same as Bob's age, so we don't expect this first portion of this block to be run. We expect this second portion. All right. This is referred to as a conditional block. Okay. So in this conditional block, we're checking to see whether the values in these variables are equal to one another, and that is why we use this equal syntax. Right. Notice that this is different than the single equal sign, which basically is an assignment operator. So 10 is being assigned to the variable Mike's age, whereas we're comparing in this case with 2 equal signs. Now, let's say if we wanted to check for whether Mike's age is different than Bob's age, we can do this, where it's not equal to Bob's age, right? And in most programming languages, this operator exists, which stands for not equal to, or bang equal to. This exclamation point is often referred to as a bang. Okay. So in this case, of course, we expect the first part of the statement to execute. And let's, for the sake of completeness, let me add something in here so you can see it in action. I'm going to write system.out.println. And by the way, I use a shortcut. I wrote sysout, and to complete the rest of this, you can just press your Control and spacebar, and that will basically fill out the rest of this long syntax. So in here, I'm just going to say ages are different. And for the sake of completeness, let me just fill this else portion out as well. Ages are same. Okay, so of course we expect the first part of this to run. And notice that it says ages are different. So when we're comparing primitive types, this is referred to as a primitive data type. When we're comparing these, we can use equals, we can use greater than or equal to, we can use less than or equal to, but when it comes to strings, it's a little different. Let me just get rid of all of this here, and let's define 2 variables, and they're going to be of type string. I'm going to say string A is equal to hello, and string B, its value is going to be there, for example. Okay. Now, if we want to check for whether A is equal to the string hello, and if you didn't know about strings, or if you're coming from a different language, you may use the comparison operator as A if A is equal to hello. Right, and this is a trap. Don't do this, right? The correct way to compare strings is we have to do a dot equals. There's a method on the string object, equals, and we do hello. Okay, so in this course, when we're comparing strings, we want to use this. Okay, so stay away from comparing strings like this. Okay, it works with integers, it works with characters, And the difference is the string is actually an object, whereas the other data types, such as integer and Boolean and so on, those are primitives. And if you want to go into the details of those differences, you can take my course on object-oriented programming. But since this course is more algorithmically driven, we don't have to worry about these little details. Just keep in mind that when you're comparing strings, you want to use the equals. And of course, I talked to you about the not. And if you want to check for whether A is not equal to hello, all you have to do is just put a bang right before the A dot equals here, and that will basically check for whether A is not equal to hello, right? Or basically A dot equals is not, okay? So the way I read this is not A dot equals, okay? So keep that in mind. This is a trap. Don't compare strings using the equal, use the dot equals. Let me show you something else. If B, which contains the value there, if B equals there, okay, then we want to do something. Let's just print out something. Printed there, okay? And when we run, you'll notice that this runs, okay? But we can also check for whether B dot equals there with a capital T, all right? And in this case, we do not expect this printed there to run. So when we play this, notice that nothing got printed because we're comparing the value that's in the variable B, which has a lowercase t, with the string there with a capital T. So to pass this condition, we can use this method called equals ignore case. Okay, and in that case, this will work fine. All right, we can have other characters in here that are all capital, right? As long as it's spelled the same, equals ignore case will work fine. All right, just like that. All right, so let me show you a few other things we can do with strings. Let me get rid of all of this to make some room. To be able to figure out what character lies in a particular index value of a string, we use this method called char_at. So we can say a.char_at, right here, this is the method, and notice the definition. It accepts an integer. So we can say, let's see what character lies in index number 3. Okay, so again, remember it starts from 0. So H is 0, E is 1, L is 2, L is 3. Okay, so it's going to get the second L here, which is at index number 3. And we could just basically print this out. And I'm just going to surround a print statement in here and hit play, and notice that it did in fact print out the second L. All right, let's see what's in 4. And it's O. And oftentimes if a string is really long and you need to figure out, if you're doing something programmatically and you want to be able to figure out the index value of a particular character within that string, this method is pretty handy. Now notice if I give a number that's way too large for this, let's say if I say 13, right? We know that this particular string is not going to have a character at the index position 13, right? So let's hit play and notice what happens. It says string index out of range, okay? So it does not accept that. If we try to give it a negative value, let's say -1, hit play, that's not going to work either. By the way, the reason I showed you this negative index example is because some languages, such as Python and Ruby, do support this sort of behavior where you put in a negative index value and basically it starts at the end of the string and works its way back. But in Java, this is not how you do it. So I just wanted to clarify that for those of you that are coming from different programming language backgrounds. All right, so add this method to your arsenal for manipulating strings. You're going to be using this a lot in the course. Now, one thing I want to bring up about the char_at method is that this method returns a data type that we have not looked at yet, and that is the char. It's similar to the string in that you can store different types of text in there, but it has to only be a single character, okay? And you surround it with these single quotes instead of double quotes as you would with strings. And the reason why it's available to us in Java is that it's much more efficient to deal with single characters using this char data type. We'll be revisiting this data type later on in some of the puzzles. But anyway, let's move on to some other handy methods in strings. The next handy method we're looking at for manipulating strings is called the index of method. And this method basically gets applied on a string to search it for a specific string value. So we pass this method a string argument, and it basically searches for that string. And the way it does this is it searches from left to right inside the given string for that particular target that we're looking at, right? And it returns the index number where that target string first occurs. So let me show you an example of this. So let me get rid of this stuff. Okay, so I've defined the string, hello there, Yogi. And what I'm going to do is I'm going to figure out where the word there occurs in this string. So we can do this, str, right? That's a string variable. We apply the index of method, and notice that it accepts, well, there's a couple of things that you can pass into it, but we're going to go with the string example. It accepts a string. So let's select that, and then the string that we want to pass in here is the one that we're looking at, and we want to search for where there occurs within this str. And what it's going to do is it's going to return the index position for where it finds there first. And I'm going to assign that to a variable, let's just say the variable is a. Okay, so we're assigning the index position where the word there is found to the variable a. All right, so let's print that so you can see where exactly it occurs. So when we play this, it starts at the index position 6, and you can count that from 0, 1, 2, 3, 4, 5, 6. Okay, that's where it begins. Now, if we had another there after Yogi, and if I was to search for, let's say 7, for example, this is the index position where we want the search to begin. Okay, and again, it searches from left to right. So index position of 7 would mean that we start at this H right here, and then we search forward. So let's hit play here, and notice that it did find there at the index position 17. Okay, so let's count where exactly it found it. So this is position 7, right? 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17. There it is. This is where it finds the next iteration of there. So again, when we put a 0 here, it will start all the way to the left, right? And it will find the first iteration of there, right, as it did here. And then if we pass in something that is beyond this point, it will basically search further in the string. Okay, so by default, there's always a 0, right? It always starts from the 0th index and searches from the left to right. If we pass in a particular value, it starts from that particular point onwards. Right, so keep this method in your mind when you're solving problems. It'll prove to be useful. Now, another thing you'll find yourself using is called the last index of method. And take a wild guess what this one does. Let's do this. B. I'm declaring a variable of type integer, and I'm going to apply the last index of method on it, on the string. And then the string that I'm searching for is, let's say I'm searching for Yogi. Take a guess what this does. Index of starts from left to right. Last index of starts from right to left. Okay, so in this case, we want to return the index position of the word Yogi in this string, starting from right to left. So it'll start from here. So let's hit play here. Okay, so we're printing the value of A. We actually need to print the value of B because we're searching for Yogi. So hit play now, and it printed a 12. So the position where it found Yogi first from the right side, searching from the right side to the left, that position is 12. So you can count from 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. This is where Yogi is first found when searching from the right. All right, and I'll make a distinction here. Let me copy this Yogi and put it right after the hello here. And now if I search for Yogi using the index of method, right? This is the regular method. This searches from left to right. So let me actually also print the value of A here so you can see the comparison. Okay, so now we're printing both A and B. Hit the play button, and notice that when we search this string from the left to right, that is, this first occurrence of Yogi is found at index position 6. But when we use last index of, it searches from right to left, and the first occurrence it finds when searching in that direction is the word Yogi right here. All right, and that index position is 17. That's where it first finds the word Yogi searching from right to left. Most of problems can be solved just using index of and the substring method along with some char at, and you shouldn't have problem solving 90% of the problems out there. But if there is ever a need or you want to explore parsing a string using this last index of, it's available to you and you're free to use it. In the next lesson, we're going to be looking at loops, and you'll be able to apply some of the knowledge that you've learned in this lesson along with loops to be able to manipulate strings, and we'll look at some example problems.